Okay. Let's go ahead and get started. So today what we're going to be doing is we're going to continue with our metric prefix conversions. But we're going to add one more twist. So thus far, we've talked about what I consider to be a one-step conversion. This is where you're given or are going to the base unit. We've talked about a two-step conversion, which occurs when you've got to move between two prefix units. Today, what we're going to talk about is we're going to talk about a conversion where the unit is cubed or squared. After that, we'll get into the English and English to metric conversions. My goal is on Friday to mix up all the types of conversions we have discussed to date and do several different problems with it all mixed up. Okay, so conversion where the unit is cubed or squared. So let's say I have 120 centimeters cubed, and I want that into meters cubed. The first thing I note is that meters, the two have meters in common. So we're still looking at the metric prefix conversions. But when I look up meter and centimeter, I find that 1 centimeter is equal to 1 times 10 to the minus 2 meters. I don't find centimeter cubed and meter cubed. I just find centimeters and meters. So what that means is I'm going to have to take this conversion factor that I did find, and I'm going to have to move it into the appropriate conversion units. So I'm going to have to take and move this centimeter into centimeter cubed. Well, in order to do so, I got to cube it, which means I got to cube the entire conversion factor. Now, what does cubing the entire conversion factor entail? It means that I have to cube the 1. It means I have to cube the centimeters. It means I have to cube the 1 times 10 to the minus 2. And I have to cube the meter. In other words, you have to cube all portions of that conversion factor. Now, 1 cubed is simply 1. So we're still talking centimeter cubed here. But 1 times 10 to the minus 2 cubed is 1 times 10 to the minus 6. and then it's meter cubed. Now, because I have centimeters cubed and meters cubed, I can actually go back and do the problem that I have shown. So I start with what I was given, which is 120 centimeters cubed. My conversion factor, I'm going to use the centimeter cubed portion in the denominator and the meter cubed in the numerator. I use the centimeter cubed portion in the denominator so that the units would cancel out, leaving me meters cubed. And now I'm ready to perform this calculation. And I get an answer of 1.2 times 10 to the negative 4 meter cubed. Yes.
This might be like a really bad way to phrase this question, but say that like the 1 centimeter for like greater than 1 or something, that also has to be cubed.
Yes, basically every part of it has to be cubed if you're cubing the unit. So let's just review this now that you have it written down, because we're going to do another one. First thing I noticed is I had 120 centimeters cubed and I wanted meters cubed. They have the term meter in common, so that means I'm using the metric prefix conversions, which is the bottom table on the tables I gave you. According to the bottom table, when I look up centimeter and meter, 1 centimeter is equal to 1 times 10 to the minus 2 meters. But you can't just use that conversion factor the way it is written, because you're working with cubed centimeters. So we had to cube the entire conversion factor so that we had centimeters cubed. Once we cubed the entire conversion factor, then we plugged it into our calculation to get the answer. Questions? Let's look at another example. $15 milliliters cubed is equal to how many microliters cubed? They do have liters in common, so we are going to the second conversion table. But when we look it up, what we have is we will find 1 milliliter is equal to 1 times 10 to the minus 3 liters. And we will find that 1 microliter is equal to 1 times 10 to the minus 6 liters. There's no cubed listed in that second table. So we've got to take the conversion factor in that table and we've got to get it to cubed. And the way we do that is by cubing the entire thing. So that's 1 cubed milliliter cubed. It's equal to 1 times 10 to the minus 3 cubed liter cubed. Or in other words, 1 milliliter cubed is 1 times 10 to the minus 9 liters cubed. We also will have to do that with the microliter. We got to cube the entire thing. So 1 cubed, microliter cubed, is equal to 1 times 10 to the minus 6 cubed, liter cubed. Or in other words, 1 microliter cubed is 1 times 10 to the negative 18 liter cubed. I want to double check that one. Yes. Now that our units are cubed, we can do this math problem. We start with the 15 milliliters cubed. The first conversion factor we're going to use is the top one, and we're going to place the milliliters cubed in the denominator with the liter cubed in the numerator. The milliliters cubed were placed in the denominator so that the unit and the substance would, so that the unit would cancel out. And I'm left with liter cubed. Then I'm going to use the second one to get into microliters. The liter cubed portion is going to go into the denominator with the microliters going into the numerator. The liter portion had to go in the denominator so that the unit would cancel, leaving microliters cubed. Since that's what I wanted to solve for, I'm ready to do this problem. And it should come out to be 1.5 times 10 to the 10th microliter cubed. Questions? Okay. The biggest mistake that people make in that particular problem, folks, is they'll cube the units without cubing the numbers. I see it time and time again. That is the biggest mistake. So now we're going to get into some English conversions. And folks, you've been doing these English conversions since forever. The metric system is less frequently used than the English system here in the United States. For example, we talk about the fact that there are 3 feet in 1 yard. For example, we talk about the fact that 1 mile is equal to 5,280 feet. These are things that I've seen done in elementary school. Maybe fourth and fifth grade. So you've been using the English system. We're just putting a spin on it because now we're going to talk about it in terms of chemistry. Or we're going to do a conversion that also requires a metric conversion involved. So let's look at an example. How many kilometers is equal to 52.7 yards? Okay. First thing that I note, there's no phrase in common. So I'm going to be using the English table. So I'm going to look for something that will help me. Let's see. I have kilometers and I have yards. And I'm just looking through here and I go, oh, well, there is something that I can use is that there's 1 yard. Is equal to 3 feet. And I keep going and I go, or I could use 1 yard is equal to 0.9144 meters. I could use the fact that a foot is equal to 0.3048 meters. There's a number of different directions I can head, in other words. Because of this fact, the English system is more difficult. So, how do you go about it? If it's more difficult, how am I going to go about it? Well, so I would do, okay, I've got 52.7 yards. It doesn't matter. I'm going to find a conversion factor that has yards in it. And I do have one that I actually wrote down, and that's 1 yard is equal to 0.9144 meters. I needed a conversion factor that had yards in it because I need to get rid of yards. In other words, the preceding unit is dictating what has to go here. And I just picked one. But I got rid of yards. Now I got meters. And I'm going, okay, can I get meters to kilometers? And then what did you just hear? Same type of unit. It's a metric system, in other words. So I can easily do that because I can go, okay, wait a second. I know that 1 kilometer is equal to 1 times 10 to the third meters. And so the 1 times 10 to the third meters goes in the denominator with the kilometer in the numerator. The meter had to go in the denominator so that the unit went away. And the answer comes out to be 0.0482 kilometers. So again, when you get the English system, it becomes a little more difficult. Could I have gone through this other pathway? Yes. Let me show you that there is more than one path. 52.7 yards. I need something with yards in it. Well, this time, instead of choosing the second one, I'm going to choose this first one. 1 yard is 3 feet. And you will see that the yards go away. And then you're left with feet. And you're going, okay, that's not the metric system either, feet to kilometers. So I'm going to go find another one. And in this case, I would go to the second one in line and go, okay, 1 foot is equal to 0.3048 meters. And the foot would have gone in the denominator so that it would have canceled, leaving me meters. Now, because I have meters and I want kilometers and they have something in common, that's where I can go to my original conversion factor that I found earlier. 1 kilometer is equal to 1 times 10 to the third meters. And the meters going into the denominator so that they'll cancel. And when you do so, you still get an answer of 0.0482 kilometers. In other words, it really didn't matter which path I took. So what matters? Somebody give me something that matters. Since it didn't matter which path I took, what did matter? The units. What about the units? They have to cancel out. I have to have whatever's here in the next one, so it'll go away. I have to have whatever's here in the next one, so it will go away. In other words, you can let your units guide you, which is another common mistake I see. And that is I see students who try not to worry about writing those units. Writing the units didn't take me very long. But they made a world of difference in making sure that it cancels out the next time. It made the world of difference to make sure that I put the correct thing in the numerator and the correct thing in the denominator. Units are important. Another important fact, and it's something I haven't stated yet. And that is you have to pay attention to what you're working with. What does meter describe? It describes length. So my conversion factors are going to be in that length column. If I want to describe volume, like quarts, cups, that's going to be over in the volume column. You have to think about what it is you're measuring. Now, I do want to make note, if I can find it, always have to figure out where's that. Ounces, that's the one. Again, you have to figure out what it is you're measuring. Because if I give you ounce, you're not going to know whether it's going to be the mass one or whether it's going to be the volume until I say ounces of liquid. And if I say ounces of a liquid, what is it? It's the volume column. But if I say ounces of meat, what is it? The mass column. So you got to pay attention. That's the only one that is confusing on this table, is the ounces. Otherwise, they're straightforward. It's either length, mass, volume, or apothecary. But ounces there's an ounce in both categories of mass and volume that you've got to be careful of. So let's look at another example. I want to let you work on that one a minute. Okay. So you should have gotten right at 2 kilograms, which is roughly 4 pounds. Give or take about 2/10. So what I did is 72 ounces of meat, because it was sirloin steak. And so I went to the mass piece and I found a conversion factor that had ounces. With that conversion factor that had ounces, the ounces had to go in the denominator so that the unit canceled out, placing the gram portion in the numerator. Then I had grams, and I'm like, okay, grams to kilograms I can do. That is the metric system. There's 1 times 10 to the third grams in a kilogram. And so the gram piece went into the denominator so that it would cancel, leaving kilograms, and it comes out to be 2.04 or 2.0 kilograms. Questions? Yes.
Okay, so, after, we do the first conversion, is the second conversion always gonna be from the bottom of the conversion chart?
Not necessarily. So how did I know that I needed to go to the bottom and not stay in the top? Because see, if you look at the one above here, this one, I used 2 in the top and 1 in the bottom. It's not, so that's actually a very good question and distinction. When I cancel out that first unit, in this case, the ounces, I got grams, correct? And I'm like, okay, grams, kilograms. They have something in common, so that's why I went to the bottom table. They had the word grams in common. Up here, however, I canceled out yards first, and I was left with feet. I was like, feet to kilometers, nothing in common. So I knew I had to use that top table again.
Okay, so how come you didn't use the one, KT equals 2.2 pounds? Because we're not asking for pounds, or what?
I could have if I needed pounds, or I could have if I'd have converted this ounces to pounds first. In other words, unfortunately, there isn't a single path you can take. You have to take, and after each conversion, ask yourself, where do I go next? What do I have compared to what do I want? And where do I go next? So there are other ways. I've given you a shortened version, for instance, of those conversion tables. There are more conversion possibilities out there. There's 16 ounces in a pound, so I could have gone 16 ounces here to 1 pound, and then 1 pound to 2.2 pounds to a kilogram. No. 2.2 kilograms to a pound. I gotta look it up. I don't know those right. I don't know the English ones right off the top of my head. Metric, you give me metric all day and I can do those off the top of my head. But English to metric, even I look up English. But that's not my point. My entire point was this is telling you where to go next. But if I'd have been asked for pounds, then yes, I could have converted that kilograms into pounds next. but I wasn't asked to go there.
Before I ask my other question, do significant digits still
On this test, I'm not going to require them, however, in active, it will.
in that sense, where did you get like the 2.0 from?
Okay,
Thinking it could be from the 72 actions.
yes. So the question is, where did I get the two significant digits from? Why did I only use two? Always, for our purposes, we're always going to go back to the original problem. And look at any numbers given to you in the original problem. Whoever's the lowest, that is gonna be your significant digits. So, it'll be in the problem. Other questions? Yes,
So on the test, you would take both answers. Well, it's not like we put just 2.0.
if you give me 2.0, you get it right. If you give me 2.04, you get it right. Only on the final will significant digits come back. And it'll be just like the questions on the last test. Otherwise, I want you to get the concepts rather than spending all your time on sig figs. Any more questions? There wasn't a I forgot to put a homework up on Monday, so you got 5 points. But there is a homework today. I think it's like 12 questions or something. To give you practice over all the conversions we've done this week thus far. And then on Friday, like I said, I'm gonna start mixing them all up. Not only will it be English to metric, but I'll start bringing back some of our molar mass conversions and Avogadro's number conversions. So it's gonna get all mixed up because that's what it's gonna be on the next test. And we've got to talk about how to identify what to do when. Because that's half the battle. I will see you on Friday. It's due tomorrow night. 11:59 p.m. I like your backpack record.
English.
Now you can get two. Oh, you're talking to the thing? I still think I gave you two, so yes, you gotta rewatch the video though.
I got one, it's like 310 in the calculator, I got 311.
But I wanna say you get 2 attempts and how I got it set up. You too.